Hi guys, welcome back to virtual session. In today's session, I'm going to discuss about the abstraction. Now, let us firstly understand what is abstraction. Abstraction is a process of hiding the implementation details and showing only functionality to the user. It means we have the implementations but don't know the background details of it. And that is exactly abstraction means. To understand abstraction, abstract means a class which provides prototype, the grammar, the implementable logic or other logic to implement to the extended class. Abstraction is for extensibility, keeping future in the reference. Developer develops abstract classes, prototypes, and that is abstraction. Just to understand the abstraction, let us consider one example. As we all know, the various shapes like circle, like triangle, rectangle, rhombus, and many more shapes. But that circle, triangle, rhombus, rectangle are the square are the last derived shape. But these all shapes are coming under the category of shape. So, as a developer, we don't know which shape or what shape we are supposed to be needed in the future. So what we need to do? We need to construct an abstract class by the name shape and declare all those methods. I'm saying declaration means only the signature of methods. For example, finding diameter of a circle, finding area of a circle, finding circumference of a circle, finding area of a triangle, square, rhombus, volume of a cylinder, and many more. Means like we need to construct a shape class keeping future shapes in a view and declare all those signature of the methods inside that. Now, when someone is going to read or view that shape class, he will get nothing. He will find only the signatures. He will find only the prototype. So the implementation details are not known to him. It's hidden. But while creating every shape, class triangle extend shape, class rectangle extend shape. So now this circle class or triangle class having their own respective properties, and it has to override that all the methods of the shape class by which it can able to find out the diameter, area, circumference of a circle, or the area of a triangle, or the area of a square and a rhombus. So an abstract class provides a grammar. An abstract class provides unimplemented structure of the methods that are called as the abstract methods, by which it provides extensibility. To understand it better in general sense, a current generation person works throughout the life, try to achieve everything in the life, but his unimplemented dreams, or keeping some objective for the next generations, he wrote some abstract methods, and that signature of the abstract methods next generation has to implement, and that is abstractions. I'm just trying to explain you the base theory behind abstraction. As we know, in the object-oriented programming paradigm, encapsulation, wrapping up data and features together to provide the data security, inheritance, to inherit the properties belongs to base to the derived, provides reusability. Abstractions provide extensibility. Polymorphism provides the feature called as one thing used for many reasons. So these are the striking features of object-oriented programming. Today we are going to discuss about abstractions keeping Java in a view. Another way, it shows only essential things to the user and hides the internal details. For example, sending SMS where you type the text and send the message. You don't know the internal processing about that message delivery. Abstract tech lets you focus on the object, what object does, instead of how it does it. Abstraction lets you focus on what the object does instead of how it does it. Means like abstractions means what, not how. That how has to define by the extended classes. Now, ways to achieve abstraction. There are two ways to achieve abstractions in Java. One is abstract class and second is interface. Now, abstract class means a class which may have defined methods, which may have constructor also, but it should have at least one abstract method. An abstract method means a method which is having the signature but don't have the definition. So abstract class means 0 to 100% abstraction, and interface means it's 100% abstractions, means interface won't consist any defined methods. It is a set of abstract methods only. Abstract class in Java, a class which is declared with the abstract keyword, is known as abstract class in Java. It can have abstract and non-abstract methods. Means, I recently discussed, to define any class as an abstract class, we need to use a keyword called as abstract. And in that abstract class, to qualify any class as an abstract class, at least one method has to be abstract type. It may consist more method than one, or it may consist abstract methods as well as defined methods as well. Non-abstract methods called as defined methods. But in case of interface, it's 100% abstraction. Hope you got it. A class which is declared as abstract is known as abstract class. it can have abstract and non-abstract methods. It need to be extends and its methods implemented. It cannot be instantiated. It means abstract class consists abstract methods and define methods, but you cannot able to create an instance of abstract class. No object can be created of an abstract class. It is actually defined for derivation, extension, not for instantiation. Points to remember: an abstract class must be declared with an abstract keyword. It can have abstract and non-abstract methods. It cannot be instantiated. It can have constructor and static methods also. It can have final methods which will force the subclass not to change the body of the methods. Abstract class may consist final methods also. Final methods means which is not extended. Abstract methods means it can be extended, and derived classes need to be implemented. So these all points actually explaining the concept of an abstract class in Java. In diagrammatical manner, I am just explaining this all the rules, like abstract class must be declared with an abstract type. It can have abstract and non-abstract methods. It cannot be instantiated. Final method. It can have final methods. It can have constructor and static methods also. So we need to understand abstraction and the abstract class and the interface. We understand the difference between abstract class and in the interface is abstract class qualifying like a normal class, but it may have at least one abstract method, and rest it can have the non-static, it can have a constructor, it can have a final method. That all absolutely possible, but you cannot create an instance of abstract class. It is defined for derivation, and interface means it's 100% abstractions. There is no defined methods are there. All abstract methods, set of abstract methods called as interface. Let us discuss this by example. In the example number 1, I construct an abstract class. While defining abstract class, you have to add a keyword called as abstract class bike. As we know, there are many bikes, Honda, maybe Pulsar, Bajaj Pulsar, and many more. So that all the bikes are actually extended. That Honda, Pulsar, these are the extended class, but they all have the common features. They are extended from the bike, and they have the feature called as run. So we will define the abstract class called as abstract class bike, which is having an abstract method run. Right? Now abstract method means every bike need to be run. So the running is a feature of that particular bike, but while constructing abstract class, it's a abstract feature. So class Honda 4 extends bike, means Honda 4 become a derived class and extends from bike. So it has to implement, it has to override a method called as run in Honda 4. So here we define the void run. So it takes Honda 4 takes the grammar of the run method from base class, abstract class, and implement that in its definition. So void run system.out.println running safely, and we are in the public static void main. We create the object of a bike, but by referring, as you said, as we said, we can't create an instance of abstract class. So it's better you create the reference of abstract class by creating an instance of or constructor of a Honda 4, or rather you construct the object of Honda 4 and give a call to the run method. Right? So Honda 4 class extends from abstract class bike bike is an abstract class because its declaration starts with abstract and it got the at least one abstract method called as run. So extended class, whether it's a Honda 4, Pulsar or any other, need to be extended from bike, and they have to implement, they have to define the method run. So the object of that particular individual class will give a call to the run method of its own, but that the grammar of the run method is taken from the abstract class. Hope you understand it. Let us go for the terminal. And compile the code. Java Honda 4.java. After successfully compilation, then we'll run it Honda 4. So Honda 4 will run safely. Right? This is one demo of abstraction. Let us go for another demonstration. Here I am defining a abstract class shape, and which is having an abstract method called as draw. So shape class is an abstract class as it have a draw as an abstract method. Abstract method means which don't have definitions, only the signature is declared. Then class rectangle, class circle, class, these classes are extending from the shape because rectangle, circle are the shape, and draw is a method they are overriding. So rectangle class override the method draw, and it is having its own definition drawing rectangle. Circle class extend shape, and it is having its own method for drawing circle. And we have a class called as test abstraction 1, which refers to the shape and draw. So if you create the instance of circle 1, you can draw the circle. If you create the instance of rectangle, you can draw a rectangle. Right? So here we need to understand that we are not creating an instance of shape. We are actually giving call to the constructor of a circle only. So here, let us say circle 1 s equals to new circle 1, and then rectangle r equals to new rectangle 1 or rectangle, and if you write r dot draw. So here an abstract class shape having a abstract method draw, and the rectangle and circle class are extending from shape, and they are overriding the method called as draw. Let us check the test abstraction. Test abstraction 1.java, and run the code java test abstraction. Here it is, drawing circle, drawing rectangle. Means we successfully able to extend a class, rectangle class and circle class from shape, and override the draw methods. Let us go for another example. That is test. We have abstract class called as bike. As I said, abstract class may have the constructor. So in the bike constructor, bike is created, and then we have a abstract method run, and then change gear. Means here I'm trying to prove the point that abstract class may have the constructor. Abstract class should have at least one abstract method, and abstract class may have the define method as well. So here class Honda extend bike, and it has to override the method called as run. And in the test abstractions, we create the object of bike, but as we cannot create the instance of, so here we'll create the object of Honda obj equals to new Honda and obj.run. So it gives a call to its own run method, and whenever you are saying obj.change gear, because of inheritance, as Honda is extended from like bike, it can give a call to change gear also, right? And whenever you create the, if you refer the object of bike s by using the constructor of Honda, it will give a call to the constructor as well. Let us firstly discuss this. So when you run this now, it will firstly say run safely, and then it will say gear changed, right? The class is test abstraction 2. So Java test abstraction 2.java. Java test abstraction 2. Bike is created, running safely, gear changed. Means whenever you create an instance of extended class, by though right now the default constructor not defined, so it gives a call to the constructor of a base class. So bike is created, and then whenever you give a call to the running safely, and then change gear change. So this is the output, you will get it over here, right? So here an abstract class can have a constructor, can have at least one abstract method, though you are not creating an instance of abstract class. Whenever the instance of derived class will be generated, whenever the instance of derived class will be generated, it gives a call to the constructor of a abstract class, and then whenever you run them, this is the run to the its own method, and then you can give a call to the define method as well. So here it proves that abstract class can have the constructor and define methods as well. Let us discuss this another example as a bank class. So we have a bank class, abstract class bank, and in the bank we have an abstract method called as get rate of interest. As we know that every bank gives the rate of interest to the consumer who had deposited the amount, at the same time taken a loan from the bank. So let us say class SBI is a bank, exchange bank. Now rate of interest is a abstract method in the bank class, right? It's abstractions. Whenever there is a bank, it has to give the rate of interest. So SBI exchange bank, and it implements its rate of interest method by offering a rate of interest 7%, and PNB extends from bank, and it offers the rate of interest that is 8. So the SBI class, RBI class get extend from the bank and implementing the method rate of interest in it. Now in the test bank, we are creating the instance of a bank by constructing SBI. So if you give a call to the now B dot rate of interest, so now B is referring to SBI, so it will print the rate of interest of SBI, that is 7%. Now B is referring to PNB. You cannot create an instance of abstract class, but you can create the instance of a derived class. So bank B, this is the reference of bank, and it is creating an instance of SBI, now referring to SBI and now referring to PNB. And when you will run this code, you will find rate of interest means there is an abstract class called as bank, have an abstract method rate of interest, and SBI and PNB are overriding that method's rate of interest, and defining its own rate of interest. So in the test bank, your bank reference is referring to SBI and referring to its own method called as get rate of interest of SBI and get rate of interest of PNB. Let us test this. Java test bank .java Java test bank. So rate of interest of SBI is 7% and rate of interest of PNB is 8%. I'm just trying to explain you various examples to understand the abstractions and how we can define the abstract methods and the purpose of defining abstract method and the extension over here. Then, after understanding the complete concept of an abstract class and the abstractions, let us go for interface. Interface is 100% abstractions, means I define interface A and I have to just declare there is no implemented methods available in it. Void A, void B, void C, void D, these all are the grammar of methods, abstract methods available over there. Now, there is no need to define abstract over here. By default, it is become abstracts. So, the class, abstract class B implements A. Abstract class B implements A. Means B is an abstract class, but it is implementing interface A. Right? So, and it is having public void C, I mean C. It means like in abstract class B, having its own defined method called as C, with print matches I mean C. Now class M extends B. Now B is a abstract class and it is implementing A. So M has to, B class don't have any abstract method, but it is implementing A. So M class has to compulsory override all those methods, compulsory define all the methods of A, B, C, D. So M class is defining this method public void A, I mean A, I mean B, I mean D, and whenever you give a call to the create the object of M, so you can even able to refer to the defined method of C class also. So in the test file, we create an instance of M by referral of A, right? Now A is an interface, right? You can create the instance of M also. So A have a reference, but creating an instance of a M. So A dot A gives a call to its own I am in A, then I am in B, then the referral of A can refer to C also. It's an implemented method of B, and then I am in D. So here this example gives how we can define interface. Interface is a solution of multiple inheritance. As you know that you cannot extend the class. Here we are using the feature of B as well, we are using the feature of A. But in case of Java, class M extends B comma A is not possible. Because of the complexities, Java will not allow you to extend your class from two base classes or two sources at a time. So we have an interface which consists all the abstract methods or all the declared methods and the class B having defined methods. So here in this case, the class M is extending from B, so it is referring the methods of B as well as it can be refer the methods of A as well. So it is as good as class M extends B comma A, but by using interface. So interface is actually defined for providing the multiple inheritance facility in Java. As you cannot extend a derived class from two base at a time by specifying comma. That is why you have to define the interface, define the abstract class. Here in this case, B is the abstract class, implements A. So the extended class of B need to override all the methods of A. So in this manner, class M is referring to defined methods of B as well as undefined methods of A as well. Let us test this. Java test5.java, Java test5. I'm in A, I'm in B, I'm in C, I'm in D. I'm posting these all the testing or tested examples in the demonstrations in my initial comment. My motive for today's session to explain you what is abstraction, what is abstract class, and what is interface, and what is the difference between abstract class and interface. Hope you understand everything well. Thank you.